Alright, this video is about variables and variable names. It is chapters 2.2 through 2.3 in the Talking Through Code textbook. So let's go ahead and get started. So I'm opening PyCharm first, right? This is the IDE, the Integrated Development Environment that we've been using for previous videos. I'm going to click on the Talking Through Code Chapter 2 project. Now that we're here, I can see my files on the left and my code is going to go over here on the right. So I'm going to create a new file. So I right-clicked on the project name, did new Python file, variables and variable names. All right, I'm gonna go ahead and hide the left pane. So we talked in the previous video about the three types of variables. There were integers, three types of values. There were integers, floats, and string values. Now that we have a variable, so variables give names to values. This is just like in algebra, right? You would have x equals 3. Now we're going to use variables for ourselves. And let's look at a variable of each type. And these are going to be assignment statements whenever we are creating variables and giving them values. So we've got whole number is equal to 30. This is an integer. We've got real number is equal to 3.14. This is a float. And we've got characters is equal to hello world. This is a string. Right? These are the three types talked about last time. And now, if I were to print whole number, it prints a 30. So the interpreter looks at as it's running. Anywhere it sees whole number, it's going to replace it with the number 30. Right? So now if we want whole number to be changed, we only have to change it in one spot if we want to. So let's look at trying to assign it the opposite direction. So right now its variable name is equal to value. What if I try to do the value is equal to a variable name? So this is a syntax error because we cannot assign a literal. And a literal is just a value that is not a variable. So literal is a value that isn't a variable. Right? So literal, that would be this 30, this 3.14, this hello world, anything that's not a variable itself. So this is a syntax error, right? Structurally, it is wrong. All right, so now that we have these variables here, we want to look at what's called a state snapshot. So I'm going to do a state snapshot for a whole number, and we'll talk about what it means for the real number and the characters. So I'm going to do whole number. So we write the name of the variable down. Then we sort of picture in memory what is happening, right? We know the information takes up actual space in the computer, so this rectangle there is to denote the space that this is going to be taking up. It's going to hold a 30 in it, right? Because we know that whole number is equal to 30. And we say that it references it, and we show references with arrows. So this is a small state snapshot of what whole number looks like in memory. We say that whole number refers to the spot in memory that is holding the 30. And a similar thing would happen for the real number and for hello world, right? We picture it as pointing to these spots in memory. Now characters, which is actually a string, strings are stored as lists of characters underneath. And so characters is actually referring to the H, and it knows how long it is, which is sort of out of scope for what we're talking about. So we're going to focus on state snapshots that look like what is drawn here. All right, so those are our state snapshots. Whenever we're looking at these variables, we have to think about how they're determining the type. So there are two ways to do it. There is dynamic, and then there is static. And in Python, these are dynamic. So we have dynamic typing. That means that the type is determined on the fly during interpretation. So, So as it's being run, it's determining the type. That means the type does not have to stay the same. So later in the code, I could say that whole number is equal to rubber duck, which is a string. So I've just changed whole number from an int to a string. This is sort of dangerous, right? If we do this, it makes it very easy to introduce bugs into our code, right? We could get confused and mistake the type of something that something is. And the reason this matters is that things like math and other operations do not work between numbers and strings. We can't, for instance, add whole number and characters together. We'll get an error. So the type really matters, and we want to make sure that we're clear about the type of our variables as we go. So it's not a good idea to do this. So this is not a good idea. So as we're going through, these types are primitive, which means they are immutable. So immutable cannot be changed. When they are updated or changed, they get a new spot in memory. So that state snapshot we did earlier, right? If we had done, I'm going to comment this out so we know it's not supposed to be there. If we had done something like whole number is equal to 15, and then whole number is equal to 7, those are two updates to whole number. So if we were going to go back to our state snapshot from before, so we've got whole number, and the first time that it runs, we saw earlier that it got 30, right? And we saw that it referenced that 30. So this is the state snapshot as of line 6. Well, then we run through the rest of our lines, and line 20 happens. So we are going to be given a new spot in memory, and that new spot in memory is what is going to hold the 15. The arrow gets put back to the 15 now, and this arrow goes away. So now there's a 30 and a 15 in memory, and at some point in the future, this 30 is going to be reclaimed. Someone else is going to be able to use that spot in memory. That's what it means. That's what garbage collection means. We're taking information that used to be referenced and is no longer being referenced and reclaiming it so somebody else can use it later. So this is the state snapshot as of line 20. Then on line 21, we're getting access to a new spot in memory, which will hold a 7. And just like before, the reference will get updated. This one will go away. And eventually, the 15 will be reclaimed because we don't need it anymore. So this is all an example of what happens under the hood because primitive values in Python are immutable. And primitives in most languages are actually immutable. So we've got that. Okay, so now imagine we've written this really long program. And in the process of writing this really long program, we have repeated the same number in a lot of places. So that number becomes what's called a magic number. So a magic number have no context in the code, right? If I'm, for instance, let's say I was repeating 30 a bunch of places. I don't know if those 30s are connected to each other. Do they mean the same thing? What is happening? So those numbers are called magic numbers, and they're fixed with constants. So a constant is a variable that's not going to change throughout the run of the program, and they go at the top of the file in all caps. So we'll see more examples of that whenever we talk about calculations. That's when it really starts to matter, right? And the benefit of a constant is I only have to change it in one place if I want to do updates, and now I understand what that 30 means as it's done throughout the run of the code. All right, so we've talked about variables, and now we need to talk about how variables are actually named. So I'm sure you've noticed that some of these variables are multiple words, right? Whole number, real number. And in order to make multi-word variables, we just stuck an underscore. So this is snake case. Underscores where spaces would be. So instead of having a space, we have an underscore. And when we talk about variable naming rules, we'll see why that is the case. So this is how variables and function names. This is how Python does variables and function names. There's also camel case, which is uppercase letters at word boundaries. And this is class names. So we'll see this when we get to classes at the end of the textbook. So those are the two things that we need to be aware of as we're naming things and as they have multiple words for their variable names. Okay, so let's talk about the rules for variable names though. And the rules we're about to talk about are rules that are enforced by syntax. If we violate these rules, the code won't interpret. So we've got some variable naming rules. Can't spell. Variable. Okay, so there are some variable naming rules. The first one is no keywords. We can't use words that already have meaning in Python as variable names. And all the rules that we're going to discuss, they're basically rules because the interpreter is not smart. It doesn't understand any sort of context. So we have these rules that are enforced to make sure that the interpreter can interpret easily without getting confused. So no keywords. They have to start with a letter or an underscore. So if they start with a letter, it's a no-go. No symbols other than an underscore. So you can't have an ampersand in the middle of your variable name. And I sort of think of this as like the hashtag rule, right? If you put like an ampersand in the middle of your hashtag, it just doesn't work anymore. So, and then the fourth one is no spaces, right? And that makes sense, right? If you have a space and the interpreter has no context, it doesn't understand that those two things are supposed to be the same variable. It sees them as two separate variables. So again, if you violate any of these variable naming rules, you'll get a syntax error. For instance, if we do 12, I think trombones is the example from the text. This doesn't work. We get a syntax error. And the syntax error does not say that the variable name isn't right. It says end of statement expected. So sometimes the errors that we get in our code don't tell us exactly what is wrong, but if you understand what the rules are for variable naming, you can sort of pick up quickly that that is what has gone wrong, is that the name doesn't work. So this is an invalid name, breaks the rules. Okay, so that's pretty much all we have to know about variables, right? We have to know the three types they can be, which is int, float, and string, and then how to create them and how to name them properly. And so these are rules that are enforced syntactically, but there are some other guidelines, right? Like we want variable names that make sense, give good context, are concise but descriptive, right? We have to be able to understand what's happening in our code, and variables help us with that. All right, so that's all I want to talk about for this. So the next video is going to talk about user input, which is chapter 2.4 from the text.